I want to talk a little bit about the radius of atoms and some of the cations of these atoms. So we're looking at metals primarily because it's the metals that form cations. And if you look, there are trends, and there are trends that we want to be able to explain. And the trends that we can see displayed here, as we go from left to right across the periodic table, the radius gets smaller, and as we go from top to bottom, the radius gets larger. Let's first talk about going from left to right across the periodic table, and that trend, which you'll notice, as we said, it gets smaller as we go from left to right. The reason for that is the effective nuclear charge, Z effective. As we go from left to right across the periodic table, the Z effective increases. That means there's a greater positive charge pulling on the electrons. Since there's more positive charge pulling on the electrons, they're pulled in closer to the nucleus, making the radius smaller. As we go from top to bottom down the periodic table, the value of N gets larger because if we think about the valence shell as we go down the periodic table, as we go from lithium to sodium, we're going from the valence electrons being in n equals 1 to the valence electrons being in n equals 2. When we get to potassium, it's n equals 3, and for rubidium, it's n equals 4. As the n number of the valence electrons increases, they are further away from the nucleus. Because the valence electrons are further away from the nucleus, the radius of the atom is larger. And this trend holds for cations as well as anions. And it's actually a little bit more important or noticeable for the cations because as we go from left to right across the periodic table, we've got a +3 charge on the nucleus compared to a +1 for lithium, comparing boron and lithium. You can see the radius goes down by almost threefold. And that's because now we have a full +3 charge pulling on those electrons, whereas for lithium we only have a +1 charge pulling on those electrons. So for the cations, not only does the effective nuclear charge increase as you go across the periodic table, but the actual charge on the ion increases. Both of these things combine to pull the electrons in closer to the nucleus as you move from left to the right across the periodic table. More charge pulls the electrons in closer. Less charge doesn't pull them in as much.